Students, welcome. Today we will see the problem on Diffie-Hellman key exchange. Okay. Let P is equals to 191 and Q is equals to 2. Alice picks X equal to 42 and Bob picks Y equal to 33. Compute the shared secret key between Alice and Bob using Diffie-Hellman key exchange protocol. This is the problem statement. First, understand the problem statement and try to read out the given values. Let P equal to 191. P is nothing but the modulus value. P value is given here as 191 and Q is 2. And Alice picks X equal to 42 and Bob picks Y equal to 33. Means here Alice is the sender and Bob is the receiver. Okay. So X equal to 42 is nothing but the random integer chosen by Alice, B 42. That is, you can make it as A, and random integer chosen by Bob, that is Y equal to 33, you can rename it as small b equal to 33. Okay. Compute shared secret key between Alice and Bob. So first, what you need to do is you need to find out the partial keys at the sending end, that is G raised to A mod P, and partial key at receiver, that is G raised to B mod P, after which you need to compute the shared secret key, which is nothing but G raised to A into B mod P. So here the generator or the base value is not explicitly given. So you can take base value G as 2. Okay. Given value is P equal to 191, G equal to 2, small a, that is random integer chosen by Alice, A equal to 42, random integer chosen by Bob, that is Y equal to 33. We can also call it as small b equal to 33. Then how to go ahead? Given value is P equal to 191, which is modulus value. Random numbers A equal to 42 and B equal to 33 and base G equal to 2. So sender is Alice and receiver is Bob. So first, sender has to calculate the partial key, that is G raised to A mod P. Okay. G raised to A mod P is 2 raised to 42 mod 191. If you do it, 2 raised to 42 mod 191 turns out to be 40. So now this partial key generated by Alice will be sent to Bob. Okay. Similarly, Bob has to calculate its partial key by the formula G raised to B mod P. G is 2. Random integer chosen by Bob is 33. That is 2 raised to 33 mod 191. So the value comes around 103. This is the partial key of receiver, and this partial key G raised to B mod P, which is nothing but 103, will be sent to Alice. Okay. Now, upon receiving partial key G raised to B mod P, so Alice has to compute G raised to A into B mod P. So for that, Alice has to apply her own random integer for the partial key received G raised to B mod P. So G raised to B mod P raised to A can be rewritten as G raised to A into B mod P. So partial key sent by Bob is 103. So 103 raised to 42. That is random integer chosen by A. 103 raised to 42 mod 191. The value comes around 115. Similarly, Alice has sent the partial key G raised to A mod P to Bob. The value is 20. Upon receiving this partial key, Bob has to apply his own random integer, which is nothing but 33. 20 raised to 33 mod 191. Answer comes around 115. Now you can see here, even though you send partial keys over here, so common shared secret key will be calculated separately in the sending end and separately in the receiving end. So here both the value matches. That is G raised to AB mod P calculated at Alice end is 115. G raised to AB mod P calculated at the receiving end is also 115. So therefore the common secret shared between Alice and Bob is 115. This is the solution. But most of the students may be wondering about how do we get this value, that is 2 raised to 42 mod 191 as 20 and 2 raised to 33 mod 191 as 103 and 103 raised to 42 mod 191 as 115, 20 raised to 33 mod 191 as again 115. So let us solve these equations separately. Okay. How to calculate, compute G raised to A mod P, that is 2 raised to 42 mod 191. Okay. So this is the bigger value. So you will not get it in a single shot in a calculator. So defactorize it. 2 raised to 42 mod 191 can be rewritten as 2 raised to 30 mod 191 into 2 raised to 12 mod 191 whole mod 191. So first calculate the value of 2 raised to 30 mod 191 separately. 2 raised to 30 mod 191 is equal to, if you do 2 raised to 30 in your simple calculator, you will get an answer like 1073,741,824 mod 191. Now we need to get the value of 1073,741,824 mod 191. Already in the previous video, I have told you how to calculate the mode value in a simple calculator. Okay, let us do it once again. So 1073,41824 divided by modulus value, that is 191. So answer comes around 5621684.94. You take out only the decimal part and multiply it with the modulus value. So if you multiply it with modulus value 191, answer comes around 1073741644. This value has to be subtracted with this number, that is 1073,741,824. Upon subtracting, you will get answer as 180. Therefore, the value of 2 raised to 30 mod 191 equal to 180. We have found out this value. Similarly, we need to calculate 2 raised to 12 mod 191. 2 raised to 12 mod 191. 2 raised to 12 is nothing but 4096 mod 191. Now we need to get this value. How to do that? Divide 4096 by 191. Answer is 21.44. Take out only decimal part and multiply it with modulus value. 21 into 191 is nothing but 4011, and it has to be subtracted with 4096 and value comes around 85. Okay. Now you have the value of 2 raised to 30 mod 191 as 180 and 2 raised to 12 mod 191 value as 85. Substitute this in equation number 1 and perform whole mod 191. Okay. Therefore, 2 raised to 42 mod 191 equal to 2 raised to 30 mod 191, which is nothing but 180, multiplied by 2 raised to 12 mod 191, which is nothing but 85, whole mod 191. So by multiplying these two values, we will get around 15300 mod 191. Now you need to get this value. Again, employ the same procedure. 15300 by 191, which comes around 80.10. Take out that decimal part and subtract with the modulus value. You will get 15280. It has to be subtracted with this value. That is 15300 minus 15280. The value comes around 20. So therefore, the partial key, that is G raised to A mod P, that is nothing but 2 raised to 42 mod 191 is equal to 20. Similarly, you calculate G raised to B mod P. How to do that? G raised to B mod P, if you do that, it is 2 raised to 33 mod 191. So it can be rewritten as 2 raised to 30 mod 191 into 2 raised to 3 mod 191 whole mod 191. So 2 raised to 30 mod 191 we have already calculated in the previous step, that is 180. 2 raised to 3 is 8 mod 191, which is nothing but 8 itself. mod 191. 180 into 8 is 1440 mod 191. So how to calculate the value of 1440 mod 191? Again, the simple procedure. Divide 1440 by 191. So you will get 7.53. Take out the decimal part and multiply it with modulus value. 7 into 191, it is 1337. It has to be subtracted with this value. 1440 minus 1337, the answer comes around 103. Now, the partial key computed by, receiver is g raised to b mod p, which is nothing but 2 raised to 33 mod 191 equal to 103. Now, next step is both sender and receiver has to calculate common shared secret key, which is nothing but g raised to a into b mod p. How to do that? Okay, g raised to a mod p raised to b, which is nothing but g raised to a into b mod p, which is nothing but 20 raised to 33 mod 191. It is very hard to find out the value of 20 raised to 33 in the calculator. So therefore, defactorizing this as 9 plus 9 plus 9, 9 plus 6, okay, which comes around 33 itself. Okay, so defactoring is it as 20 raised to 9 mod 191 into 20 raised to 9 mod 191 into 20 raised to 9 mod 191 into 20 raised to 6 mod 191 whole mod 191. So 3 times 20 raised to 9 mod 191 is there, and first you calculate that value. So 20 raised to 9 mod 191, if you do so, this is the value mod 191. You subtract the given number by modulus number, so you will get this number. So take out only the decimal part, and the decimal part has to be multiplied with the modulus value. You will get one value. This value has to be subtracted with 512,000,000,000,000. So if you subtract this, you will get answer as 48. Now we got the value of 20 raised to 9 mod 191. Similarly, you calculate for 20 raised to 6 mod 191. So by calculating 20 raised to 6 mod 191, in a simple calculator, you perform 20 into 20 into 20 into 20 into 20 into 20, 6 times. So answer is 64,000,000,000,000. Okay, and mod 191. So how to calculate this value? First, divide the given number by modulus, and you will get one number. You take out only decimal part, subtract it with the modulus value, and the result will be subtracted with the 20 raised to 6 value, that is 64,000,000,000,000. So the answer is 102. So now you got the value of 20 raised to 6 mod 191 as 102. Now you substitute these two values in equation 2. Substituting these two values in equation 2, okay, substitute this value in the equation 2. 20 raised to 9 mod 191 is nothing but 48. Here also 48, here also 48, and 20 raised to 6 mod 191 is 102 raised to mod 191. So if you multiply these values, it will come around 112,803,84 mod 191. So you need to find out this value. Again, employ the same procedure, divide this by this, you will get a number, take out only decimal number and subtract it with the modulus value. You will get a result. The result has to be subtracted with this particular value, 112,803,84. So the answer comes around 115. Therefore, 20 raised to 33 mod 191 is 115. So this is at one end. Okay. Similarly, at the receiving end also, you need to compute shared secret key. Okay. We will do it at the receiving end now. So 103 raised to 42 mod 191. So 42 is a bigger number. So it can be defactorized as 7 into 6. That is 42. 42 means 6 plus 6 plus 6 plus 6. You can defactor like this. So 103 raised to 42 mod 191 can be rewritten as 103 raised to 6 mod 191 into 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 103 raised to 6 mod 191. So 1, 2, 3, 4, 5, 6 and 7. Whole mod 191. So almost all the values are same. You at once only you calculate 103 raised to 6 mod 191. So by calculating, you do it in a calculator 103 raised to 6. So you will get this value and you apply with mod 191. So again, you do it in a simple calculator. So divide this number by this number. So it comes around 625,1582704.30. So you take out only decimal part and multiply it with modulus value. On doing so, you will get this number. It has to be subtracted with this given number. So if you do so, the answer would be 65. Now we have found out that the value of 103 raised to 65 mod 191 as 65. So substitute 65 over here in equation number 3 and apply it with whole mod 191. Okay. By substituting it in the equation, so 65 into 65 into 65 into 65 into 65 into 65 into 65, 7 times, mod 191. So by multiplying this, the value comes around 490,222,789,0,625 mod 191. So how to get the value of this? Again, do it in a simple calculator. Divide this number by this number. So take out the decimal part. So decimal part has to be multiplied with the mod value. So you will get a result. The result has to be subtracted with 490,222,789,0,625. So the answer would be 115. So therefore, 103 raised to 42 mod 191 equal to 115, which is nothing but G raised to A into B mod P as 115. So here, both at the sending end and both at the receiving end, so they have to calculate the shared secret key. So G raised to AB mod P. So in both ends, we have got answer as 115. Okay. So now this key will be used by sender and receiver. So in order to encrypt and decrypt messages henceforth. Okay. It can be employed with symmetric key encryptions like advanced encryption standard. I hope you understood the problem. Thank you.